Today, we'll be looking into a chemical engineering question from GATE 2020, question number 24. The decomposition of acetaldehyde X to methane and carbon monoxide follow four-step free radical mechanism. The overall rate of decomposition of X is minus Rx is equal to K2 into K1 by 2 K3 the whole raised to 1 by 2 Cx raised to 3 by 2. Which is equal to K overall into Cx raised to 3 by 2, where K1, K2, K3 denote the rate constant of the elementary step with corresponding activation energy in kilojoule per mole of 320, 40 and 0 respectively. The temperature dependency of the rate constant is described by Arrhenius equation. Cx denotes the concentration of the acetaldehyde. The rate constant for the overall reaction is K overall. The activation energy for the overall reaction in kilojoule per mole is dash. So this is a question from reaction kinetics part from chemical reaction engineering, and the reference NPTEL lecture can be found in week 1 lecture 3 kinetic model and temperature dependency chemical reaction engineering 1 by Professor B. Mandal, Department of Chemical Engineering, IIT Guwahati. So here they have given us the rate equation. So the rate equation has three rate constants K2, K1 and K3. So we can write K overall is equal to K2 into K1 by 2 K3 the whole raised to 1 by 2. So it is also given that these rate constants follow Arrhenius equation. So we can write or expand the rate constants K as K0 into e raised to minus e by RT, where minus e is the activation energy, R is the universal gas constant and T is the temperature and K0 is the frequency factor. So we can apply this expansion via Arrhenius theorem for all the rate constants. So we can write K overall, which is equal to K2 into K1 by 2 K3 the whole raised to 1 by 2 as K20 into e raised to minus E2 by RT into K10 e raised to minus E1 by RT by 2 into K30 e raised to minus E3 by RT the whole raised to 1 by 2. So this will be equal to K overall into e raised to minus E by E overall by RT. So now what we can do is we can write the exponential terms or equate the exponential terms in the right hand side and the left hand side. So we can rewrite this as just in terms of the exponential terms as e raised to minus e overall by RT is equal to e raised to minus E2 by RT into e raised to minus E1 by RT by e raised to minus E3 by RT, the whole raised to 1 by 2. If we expand on this, we can write this as e raised to minus E2 by RT plus minus E1 by 2 RT minus E3 by 2 RT, and this will be equal to e raised to minus E overall by RT. So we have the values for E1, E2 and E3. All we have to do is substitute these values in this equation to find the overall activation energy. So E1 is given as 320, E2 is given as 40 and E3 is 0. E raised to minus E overall by RT is equal to e raised to minus E2 by RT plus e raised to minus E1 by 2 RT minus E3 by 2 RT. So now we can just equate the exponentials itself or the powers of this E. We can write the equation as minus E overall by RT is equal to minus E2 by RT plus minus E1 by 2 RT minus E3 by 2 RT. So first we can cancel all the RT terms from the equation, and now we can just substitute the values. So minus E overall is equal to minus E2 minus E1 by 2 plus E3 by 2. So we have E1 is equal to 320, E2 is equal to 40 and E3 is equal to 0. So if we substitute these values, we can get the overall activation energy E overall minus E overall is equal to minus 40 minus 320 by 2, and E3 is 0, so we can neglect that term. So this will be minus 40 minus 160, and that is minus 200 in kilojoule per mole. So this is minus E overall, which is minus 200. So E overall will be 200 kilojoule per mole. So the overall activation energy is 200 kilojoule per mole. Thank you.